So homework 18, we are applying the quadratic formula. When we solve a quadratic equation, there's lots of ways to solve it. You could solve it by graphing and finding where it hits the x-intercept. We already solved it by factoring. Another way is using the quadratic formula. The nice thing about the quadratic formula is it works all of the time, where factoring doesn't always work. If you tried to factor this one, it'd never work out. So the quadratic formula says, if I have the wrong pen, writing these. Now it should be the right pen. If I have ax squared plus bx plus c equals 0, my quadratic equation in standard form, the coefficients are the a, b, and the c, and that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. No, I don't expect you to memorize it, although it probably doesn't hurt to have it memorized, but like I said, you can use your notes if you forget it when you're doing your assessment, so you can always look it up on your homework page. So, if I look at my quadratic equation and I have 5x squared plus 9x plus 2, the a value is the 5, which is the coefficient of my x squared, the b value is the 9, and the c value is the 2. So plugging into my quadratic equation, I have minus the b value, which is 9. I'm going to put it in parentheses just because it looks good. Plus or minus the square root of the b value, which is 9 squared, minus 4 times the a value, which is 5, times the c value, which is 2, over 2 times the a value, which is 5. So anytime I substitute in for a variable, I put it in parentheses just to separate it from all the other stuff that's in there, and then I can go ahead and simplify from there. So here, if I just have minus my 9, obviously that's going to be negative 9. Plus or minus, I've got to simplify all of this mess. 9 squared, 9 times 9 would be 81. Minus 4 times 5 times 2 looks like negative 40. I multiplied that right. 81 minus 40 then gives me 41. And then on the bottom we have 2 times 5, which is 10. Now unfortunately on the ALEKS program they don't give you the option of plus or minus. They want to point out that it's really 2 separate answers. So they make you put it in twice. You're going to have to put in negative 9 plus the square root of 41 over 10. And negative 9 minus the square root of 41 over 10. Be careful when you put it in that the negative goes on top the fraction with the 9. It's not out in front of the fraction. And that the fraction is over the whole entire thing, not just underneath the square root. So what I would do when I type it in is hit the fraction option first, type the bottom in, then tab, type the top in. I also highlight that, Control-C copies, Control-V pastes, and then I just have to change the sign and I don't have to type the whole thing in. So that's what that looks like. And I type that in. If I move down there to number 2 then. Again, I'm going to have minus b plus or minus the square root of b squared minus 4ac over 2a. And so in this one, my a value is going to be 9, my b value is negative 5, and my c value is negative 1. So plugging that in, I'm going to have minus from the formula, and in my parentheses, negative 5. Minus a negative 5, which we'll simplify in a minute, plus or minus the square root of negative 5 squared, minus 4 times the a value, which is 9, times the c value, which is negative 1, all over 2 times the a value of 9. So simplifying that, if I have minus a negative 5, going to change to a positive, right? That always should end up being the opposite of whatever the b value is, because that's what minus b means. So 5 plus or minus negative 5 squared would be 25, right? When I square a negative, it becomes positive. Negative 4 times 9 times negative 1, again, that's going to be positive 36 then. And so if I take 25 plus 36, I would get 61. And if you're using your calculator, you might as well punch the whole thing in at one time. Over my denominator, 2 times 9, which is 18. So I have 5 plus the square root of 61 all over 18, and 5 minus the square root of 61 all over 18. Now on some of these you are going to be able to simplify further. If you would have had the square root of 63, you could have factored it into 9 times 7 and made it 3 square root of 7. And sometimes you can even reduce it. But the directions on these ones do not say you have to simplify. So if I would put it in there with the square root of 63, if that were the answer, it's still going to be correct. It's going to say it's correct. However, you could have simplified it. So it's up to you if you want to simplify it or not. It's good practice, but you don't have to do it. Third one here. My a value is going to be 3, my b value is also 3, and my c value is negative 7. So if I plug those into the quadratic formula, what would I have?
Negative 3 plus or minus the square root of 3 squared minus 4 times 3 times negative 7 all over 2 times 30.
So again, I really don't need the parentheses around the 3, but just to, for sake of properness, I have minus the 3, so we can just write that as negative 3. 3 squared would be 9. Negative 4 times 3 times negative 7.
84.
Positive 84. 9 plus 84 then would be 93 over, or 2 times 3, which is 6. And again, I don't think I can simplify the square root of 93. So we would have negative 3 plus the square root of 93 all over 6, and negative 3 minus the square root of 93 all over 6. So when you're on the ALEX program, even on the assessment, it's going to tell you use the quadratic formula. So if it says that, you know it's not going to factor. Don't even waste your time. Next ones, you're still going to use the quadratic formula. It says find all complex solutions. So if it's a complex solution, it may or may not have an imaginary number part. So sometimes we'll get a real number answer, sometimes we'll get one with the imaginary number answer. So again, I'm going to say my A is 2, my B is negative 3, and my C is negative 7, and I'm going to plug those into the quadratic formula. So minus the B value of negative 3 plus or minus the square root of negative 3 squared minus 4 times the A value of 2 times the C value of negative 7 all over 2 times the A value of 2. So simplifying that. Again, if I have minus a negative 3, it becomes positive 3. Negative 3 squared, oh, this one's going to come out to a normal one. Negative 3 squared is 9. Then I have minus 4 times 2 times negative 7, which would be 56 plus 9, so 65 over 4. So this one just turned out the regular way. We didn't even get an imaginary number, which will happen even though it says complex solutions, because complex numbers could mean you have 0 i's. And so again, we'd have 3 plus the square root of 65 over 4, and 3 minus the square root of 65 over 4. So number 5, A is going to be 4, B is going to be 5, and C is going to be 2. If we plug that into our quadratic formula, what would we have?
-5 plus or minus the square root of 5 squared minus 4 times 4 times 2 over 2 times 4.
So we're going to have -5 plus or minus the square root of 5 squared is 25. -4 times 2 would give me -32 if I did that right. So 25 minus 32 would give me -7 all over 8. Now, again, this doesn't tell you to simplify, and it doesn't tell you it has to be in standard form. So I found it's easier for me to type it in if I do -5 plus I square root of 7 over 8 and -5 minus I square root of 7 over 8. However, if I want to do it in the best form that it is and put it in standard form, since I have imaginary numbers, I would have -5/8 plus, and then we'd have the square root of 7/8 I, and then same thing with the minus. So it's up to you. If you want to separate it and put it in standard form for complex numbers, you don't have to. You can put it in like this. It's easier for me to get it all typed in by just putting the I in front of my square root, although it's not the best way. But they don't care. It's correct either way. Number 6 then. Our A is going to be equal to 2, B is -1, and C
6.
is 6. So substituting that in, we're going to have minus our -1 plus or minus the square root of -1 squared minus 4 times 2 times 6 all over 2 times 2. So simplifying that, we are going to get
1 plus or minus the square root of 1 minus 4 times 2 times 6 over 4.
And so if we figure out what should be underneath the square root, minus 48.
No, 1 minus.
Oh, 1 minus 48. See, I didn't figure it out. 1 minus 48 is -47. Darn, I was hoping we had one we could simplify, but again, we got something we can't really simplify. So again, we're going to have that imaginary part. If I put it in standard form, I would have 1/4 plus the square root of 47/4 I. And again, be careful that that 4 doesn't end up under that square root. And then 1/4 minus the square root of 47/4 I. It's easiest if you're going to do it that way to hit the fraction buttons first so that the square root doesn't go over the whole fraction, just over the numerator. Seven, 8, and 9 are talking about the discriminant of the quadratic equation. The discriminant comes from the part of your quadratic formula that's under the square root, the b squared minus 4ac. If that is a positive value, you get 2 real number answers because you have plus or minus the square root of something, right? So you get 2 real number solutions. If it is exactly 0, you would have plus or minus the square root of 0, which gives you the same number twice, so you actually only end up with one real number solution. If it's negative, then you get one of those imaginary number solutions, which is not a real number solution, and so they say you have 0 real number solutions. So sometimes when you're doing a word problem, before you do it, you can quickly check the discriminant to see, am I going to even come out with a real number answer or not? If I'm not, there's no point in doing all the calculations unless you just like to do the quadratic formula. So they're going to just have you check the discriminant part out to say what the value is that would be under the square root, and then how many real solutions would you get if you have that under the square root. So again, A is going to be -5, B is going to be -1, and C is going to be -4, and you're just doing the B squared minus 4AC part of your quadratic formula. So, -1 squared minus 4 times -5 times -4. If we figure that out, -1 squared is 1. -4 times -5 times -4 would give me -80. 1 minus 80 is -79. So my discriminant in this case would be -79. Since it's negative, how many real solutions do I get? I don't get any because I'm going to get imaginary number solutions. So number 8, my A value would be 2, my B value is -6, and my C value is 0, right? So sometimes they'll leave one of your terms out, which is perfectly fine. We just put a 0 in for that value, and then we figure out our discriminant. So B squared minus 4AC means I'm going to have -6 squared minus 4 times 2 times 0. So if I figure out what that value is, I would get try that again. 36. -6 squared is 36. Anything times 0 is 0. So I just get 36. And if my discriminant is a positive 36, how many real solutions would I get? 2. And so number 9. I have A is -3, B is -6, and C is -3. So if I do my B squared minus 4AC, what would I do to figure that out? Plugging my numbers in, I'd have -6 squared minus 4 times -3 times -3. So -6 squared is 36. -4 times -3 times -3 is -36. And 36 minus 36. Hey, the value of my discriminant is 0, and if the value of my discriminant is 0, how many real solutions do I get? 1. All right. Now the next one's still using the discriminant of the quadratic equation, and this time they're either going to say, well, what value would give me 1 solution, 2 solutions, or no solutions? So positive numbers, I would want to say greater than 0. If I have one solution, equal to 0, and if I want negative answers, I'd have to say less than 0. So in this case, I'm finding all the values of j, which happens to be right here. It's part of my c value, for which we have one real solution. If we have one real solution, our discriminant has to be exactly equal to 0. So b squared minus 4ac equals 0. My a value is 2, my b value is 6, and my c value is that whole weird thing there, minus 4j. So I'm going to have 6 squared minus 4 times 2 times negative 4j equals 0. And then I'm going to solve that equation. So 6 squared is 36. Negative 4 times 2 times negative 4j is going to be positive 32j. So I'm going to subtract my 36. 32j equals negative 36, and I'm going to divide by 32. J is going to be equal to, and if I simplify that fraction, I would get negative 9/8. So this one you do have to type the whole thing in, because sometimes you'll have a greater or a less, or in this case we had the equal. So on the next one it says find all the values of k for which the quadratic equation has 2 real solutions. If it has 2 solutions, we know that it has to be a positive number. So we know b squared minus 4ac has to be greater than 0. A is going to be 4, b is going to be negative 5, and c is going to be 3k. So negative 5 squared minus 4 times a is 4 times c is 3k has to be greater than 0 in order to make that a true statement. So solving that, we would get minus 48k is greater than 0. Next thing you might want to do is subtract the 25. Sounds good. So negative 48k is greater than negative 25. And then we're going to divide by our negative 48, so we end up with k is less than 25/48. I don't think you can reduce that down, and so that's going to be my answer. So again, if we have an inequality and we divide by a negative, we end up flipping our sign. So we had one where it said one real solution, where we said, I almost drew underneath there, where we said it equal to 0. 2 real solutions, we said greater than 0. The third one, it's going to say no solution. So number 12, if I'm finding the value of h for which the quadratic equation has no solution, then the b squared minus 4ac would have to be a negative number, so would have to be less than 0. So those are the 3 ways you're going to have to see those to set those up. And so a is going to be 2, b is going to be 7, and c is going to be 2h. So 7 squared minus 4 times 2 times 2h is less than 0. So solving that, we would get
49 minus
16h is less than 0 then. If If we're going to solve that, we would do what next? Subtract your 49 would work. So negative 16h is less than negative 49. And then, of course, we're going to divide. And so our answer is going to be
H is greater than 49 sixteenths.
h is greater than 49/16. All right. So, when we're doing our word problem with our quadratic equation, I notice in my word problem it says round your answer to 2 decimal places. Tells me it's probably not going to factor because I'm going to get a decimal number and it'd be really hard to factor that way. So I'm going to have to use the quadratic formula and then use my calculator to evaluate my quadratic formula. It says when a ball is thrown, its height in feet h after t seconds is given by the equation h equals vt minus 16t squared, where v is the initial velocity in feet per second. If v equals 23 feet per second, find all the values of t for which h equals 8 feet. Do not round any intermediate steps. So I'm throwing my ball up. I want to know when it's at 8 feet, and then it's going to go up and around, when it's at 8 feet again, and then it's going to hit the ground. So I'm going to get 2 answers in most cases. V is going to be 23, h is going to be 8, so 8 equals 23 minus 16t squared. Now I have to set that equal to 0. In this case, when you use the quadratic formula, it doesn't really matter if your t squared is negative or not. I just don't like it to be negative. So I'm going to move these over. Whoops, I better put my t behind my 23. There was a vt. So I'm going to use 16t squared minus 23t plus 8 equals 0. And I'm going to move these things over here just because I like my t squared positive. So plugging into my quadratic formula, I'm going to have minus that negative 23 plus or minus the square root of negative 23 squared minus 4 times a is 16 times c is 8 over 2 times a, which is 16. So again, since I have minus a negative 23, that's going to make that positive 23, plus or minus the square root of, and just figure out what the number under the square root is for me. You got calculators, so just plug the whole thing in, unless you want to do it in 2 steps. I know the bottom's 32. $15? 17? You girls getting 17? You get 17, Dan? Nobody knows? You're the only one who did it, Gavin. They're just waiting for you. Gavin says it's 17. I don't know why I didn't do it. All right, so when we calculate that, if we're going to use our calculator, either you need to put parentheses around the top part of that fraction, or you have to hit equals after you put the top in. I just like to use the parentheses. So I would do 23 plus the square root of 17 divided by 32, and then 23 minus the square root of 17 divided by 32. So if you calculate the top there, 23 plus the square root of 17, and then divided by 32, says round your answer to 2 decimal places. That means 2 places after the decimal, or the hundredths place would be the same thing. Punch that into your calculator, you get
.12. So that rounded would be what? 3.
That seems kind of big. Nothing can be right. Is that what we got, Dan?
No.
No?
I got, for the positive one, I have 0.85.
That's what I got.
0.85,
Yeah.
okay?
And for the other one, I got 0.59.
0.59. Did you use the parentheses, Gavin, when you put that in there?
I don't know, I did some.
You did something? If you don't use the parentheses, do it this way. 23 plus the square root of 17, hit equals, and then hit divided by 32. What did I hit? I could say a different answer yet. 23 plus square root of 17 equals divided by 32. There, now I got the right thing. 0.85. All right. So, we're going to have two answers. T. T is going to equal 0.85. I can't remember if this one has a thing that you have to click or if you just put a comma. Nope, there's a button. You have to hit the button that says or and then put in the 0.59. They have to change these all the time. So, on number, let's see, that was 13, 14. Number 14, a ball was thrown from a height of 156 feet. So I might be standing on top of the building and I'm going to throw my ball down. Has an initial downward velocity of 8 feet per second. The ball's height in feet after t seconds is given by the following. How long after the ball was thrown does it hit the ground? Well, if it hits the ground, its height's going to be 0, right? Round your answer or answers to the nearest hundredth. Well, if I'm throwing the ball down and it's going to hit the ground, I'm probably only going to get one answer, right? It's not going to, well, it might hit the ground more than once if it's bouncing, but they just want to know the first time it hits the ground. So h, my height is going to be 0. I have 156 minus 8t minus 16t squared then, since I don't have to substitute anything in. This one, since it's already set equal to 0, we might as well just leave it in that order and plug it into our quadratic formula. So, minus our b value, plus or minus the square root of negative 8 squared minus 4 times the a value, which is the negative 16, times the c value, which is 156, all over 2 times the a value, which is negative 16. So, if I have minus a negative 8, obviously going to be positive 8. Plus or minus. I'm going to let you guys use your calculator and figure out what that number under the square root should be. Well, I answered Dennis's question.
I didn't catch how they were doing the exponent.
So on the exponent, if it's a plain squared, you can use that button. If it's cubed, you can use that button. Anything else, you have to use the caret key. So if I'm doing 2 to the 5th power, it's going to give me 32, because if I took 2 times 2 times 2 times 2 times 2, that's 32. So that caret key can do any exponent. You can even do the squares and the cubes if you always want to use that button.
Okay.
All right? What did we get underneath the square root? It's going to be a big number. I don't know what it is.
I got 2,048.
2,048?
10,000.
10,048. 10048. Everybody else get that? They're nodding. They say they got the same thing, so that must be it. Over negative 32. So, either the plus or the minus one's going to work. One of those two. We have to figure it out. So, 8 plus the square root of 1,000, or 10,048 divided by negative 32. That one's probably not going to work because that's going to give you a negative answer. 8 minus the square root of 10,048 divided by negative 32, yeah? Got to be the bottom one because top one's going to give me a negative answer, and we know it can't be a negative answer. Rounding to the nearest hundredth, what are we getting for our answer? $2.88, that's what I got. 2.88. Everybody else get that? All right, good. The other one gave you a negative, and that's not going to work. We can't have a negative time. Number 15 then. A ball is thrown from an initial height of 1 meter with an initial velocity of 20 meters per second square, or 20 meters per second. The ball's height in meters after t seconds is given by the following. H equals 1 plus 20t minus 5t squared. Find all the values of t for which the ball's height is 11 meters. So we want to put 11 in here for the h. 11 equals 1 plus 20t minus 5t squared. We, of course, need to set that equal to 0. So if you set that equal to 0, you're going to have what?
Negative 10 plus 20t minus 5t squared. Do you want to know that?
We can do it that way. So he subtracted the 11, had negative 10 plus 20t minus 5t squared. And so, putting that in, b, so I'm going to have minus the 20 plus or minus the square root of 20 squared minus 4 times the a value, which is negative 5, and the c value, which is negative 10, over 2 times the a value, which is the negative 5. So negative 20 plus or minus the square root of, and what kind of mess do you get under the square root this time?
Good.
200 over negative 10 then. So again, we still should end up with 2 answers because we're starting at a height of 1, but it's going to hit 11, get to the top, hit 11 again. We should end up with 2 answers. So we're going to have negative 20 plus the square root of 200 divided by negative 10, and then negative 20 minus the square root of 200 divided by negative 10. And what you get for your first answer? You got what?
5-8.
Did you round it up
1-6.
to the 100th? Does it say 100th? It does. So 0.5. Yeah, I gotta round that up to 9 because there's a 5 behind there, right? So 0.59. And then if we do our other one,
we get
3.41.
3.41, that's what I got. 3.41. Would be our two answers then.